Number 10, we've got an equation with y equals 3 cosine 2x, and we've got this line, 2y plus 3x over pi equal 5. They want to state the smallest and largest values of y for each one. So basically they're asking for the range of each one within this domain of 0 to 2 pi. Alright, so we can do that. First, this one is a periodic function, and we can see that the midline is going to be 0. And we can see that the amplitude is going to be 3. So it should be pretty easy to predict that the highest point is going to be for y 3 and the lowest one is going to be a negative 3. Now looking here, it's a line, so I decided to get the y by itself, and when I'm dividing by 2 it's the same thing as multiplying by 1/2. I am going to divide the 5 by 2 and get 2.5. And so then I end up with this. And now all I've got to do is, well, see this, when I put a 0 in here, if I put a 0, which is the lowest x I can use, y's got to be 2.5. Alright, that's easy enough. And then I can replace the x with a 2 pi, which is the highest x that I can put in there. And that's going to give me 3 times 2 pi over 2 pi. Plus 2.5. Obviously the 2.5's cancel out, leaving me with y equals negative 0.5. So with the line, the smallest value is negative 0.5 and the biggest one is positive 2.5. So now in part 2, it says sketch on the same diagram both these graphs. Okay, so I know how big the one has to be. The y's have to be plus or minus 3, and the other one is going to go to 2.5. So I'm going to go ahead and put together this graph. I'm going to put my points, pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to go ahead and go 1, 2, 3, and negative 1, 2, 3. And so I'm going to plot my points. The amplitude is 3, and the frequency is 2. And I see that that means that I'm going to get one full cycle in a 1 pi time frame. So I go ahead and cut these points in half. I get my calculator, and let's see, if I put a 0 in there, 3 cosine 2 times 0 is 3. That gives me my first point. And then I put in pi over 4, which will give me a 0. And then I go ahead and plug in pi over 2, and I get a negative 3. And then I put in a 3 pi over 2, and I get another 0. I'm sorry, 3 pi over 4. And then I put in a pi, and that gives me a positive 3. And there's my one complete cycle. And see, once I've got this, I should be able to figure out what the next cycle is going to be. I can anticipate this is going to just repeat itself. I'm going to figure it all out again. That one point, there's another point, there's another point. It's going to make another very same kind of U-shaped kind of guy here. I want to make sure it flattens out as it gets to the extremes, but that's about it. And since there's going to be more than one graph on here, I probably should go ahead and label this y equals 3 cosine 2x. And then the other one's a line, and I know the y-intercept for that. That's going to be 0, 2.5. I know it's got a negative slope, and I know the other one's going to be 2 pi negative 0.5. So I can plot these points, and I know it's a line, so I just got to connect them. And there you go, I've got both graphs, and like I said before, if I've got more than one function on a graph, I should label them. And that's that. Now in part 3, what they want us to do is they want us to state the number of solutions that the equation 6 cosine 2x plus 5 minus 3x over pi, and we should write that down because it's not exactly what we had the last time. 6 cosine 2x and 5 minus 3x. Now, the line, I mean, if I write these with y equals, it's going to look like this. Now, if you take a look, the first one was y equals 3 cosine 2x. And the other one was y equals, where is that over here? Negative 3x over 2 pi plus 2.5. So what we've got to do is take into account that it's not quite the same. The new guy has got an amplitude of 6. Now keep in mind, it's not going to shift him left and right, but it is going to make them taller. So I'm not going to go any crazy. You don't have to even draw this, but I want to give you a kind of visual here. What the amplitude's been increased, it's going to kind of look like this compared to up and down 3. Now, if I take a look at this line and I put a 0 in here, well, then my y-intercept is going to be 5. And then if I put in a 2 pi where the x is, then the pi's are going to cancel out, but it's going to be 5 minus 6 or negative 1. So what's going to happen is my line's going to kind of look like this. Let's see if I can get a good one. There you go. And the points of intersection are the number of solutions. So the fact that I've changed the line a little bit and I've changed the amplitude doesn't affect the number of times I have intersections, and I'm going to say the ending answer is 4. So I hope that helped. Thanks for watching.